program for calculating velocity. So those of you that had a physics class, you might recognize the velocity equation that we see down here towards the end. Final velocity is whatever initial velocity you start with, the v0, plus the quantity of velocity that can be found by acceleration times time. So it's just one of the most basic equations of motion. Basically, a final amount of something is equal to an initial amount of something plus the change in that same kind of thing. In this case, we have three different variables here. So you'll notice here that I've commented out these things that you would probably get used to including in all of your future programs, especially the ones where you're doing math, but we end up not needing it in here, and you'll see this will run just fine with these commented out. So have some good comment code here. You want to get in the practice of doing this. So basic variable, well, I'm going to let the user input it. We're keen on doing that. What's the initial velocity in meters per second? Um, these right here, we don't have to worry about those right now. We'll come back and deal with that later. I set initial velocity 0. I make acceleration 1, and so we can comment that out also, since we have asked for it in the problem here, but we always let the clock start at 0. And so these are just basic stuff. I think you can read your way through those, and in fact, I think I'll probably just get rid of these things, because as I recall, I was just playing around. So let's look at this loop structure. We did an if loop a while back, but there's a while loop, and I kind of like these better, but sometimes the if else lends itself to the problem you're doing. And you can even put an if statement in the while loop. You can nest them with each other. So while time is less than 10, so I'm going to let the clock run for 10 seconds. What we want to do is we want to calculate the velocity based on the user input of initial velocity, the user input of acceleration, and the time that's running on a clock. Down here is where we see time running, because at the end of the loop, before it goes back and tests, I add a second. And so after we calculate the first velocity at some time t, we print at time, so that's in quotations, and then I concatenate. That's what we're doing here, concatenation. And I have to turn the value t into a string, because you can't concatenate strings and integers in this version of Python. So then I concatenate it with a comma, so we have good grammar. English teachers will be happy. Concatenate again with the rest of the sentence. The velocity is. Concatenate it with the string conversion of the value of velocity as it is this time through the loop. Now here's the trick. In order to update the next time around, I've got to let initial velocity for the next time we come around and into the loop be what it was the first time through the loop. And so the value that we obtained here will become the new initial velocity at time whatever, 1, 2, 3, 4, 5. Then of course we've got to increment the time. And then we come back up here to the loop, and it tests is t less than 10. Well, initially it was 0. We added 1 to it, so 1 is less than 10. Do it again, but recall velocity initial will no longer be what it was up here. It'll be what it was calculated to be in this equation, and then passed into the variable final velocity, or initial velocity. And so let's run this puppy. Okay, better save it. What is the initial velocity in meters per second? So let's say that it's 0. So let's say it starts from rest at time 0. What's the constant acceleration? Let's give it an acceleration of 1. Uh-oh. Wonder what happened. I don't recall editing anything that wasn't already commented out. So let's see what happens here. All right, well, that'll be an interesting problem. Now I got homework. Go figure out what I did uh, by adding back in commented out code. But here is the way I expected it to work, and that's the way it goes in this game of programming. Based on my input, so at time 0, and initial velocity is 0, acceleration is 1, but time is 0, so at time 0 we haven't moved yet. We're just like getting ready to. So the velocity is still 0. Then at time 1, when the initial velocity at time 1 would have been what it was at time 0, but 1 times 1, because acceleration is 1 and the time value is 1, 0 plus 1 is 1. And then that continues all the way through, and we've basically calculated step by step, piecewise, the velocity at some given time t.